Hi students, welcome back. This part is associated with differentiation rules. Till now we have just considered a function, learned how to differentiate and what the differentiation means geometrically. Now here we are making things a bit complex. We will be starting with maybe functions in functions. There can be cases when two functions are multiplied, divide. So we are going to consider some rules whenever we are encountering some different case. And again, this is not all, okay, we will be learning more rules as we proceed with the journey. But here we will be basically dealing with the general basic rules which are very important for doing the differentiation of composite or the higher order functions. Let's begin with the part.
Let us look at some differentiation rules. Okay. Till now we have discussed only when a function is given that how we are going to differentiate. At times you will find that the function is not directly differentiable. Like it may be combination of two functions. Then what to do in that case? Okay. So obviously we will see some rules for that. Now till now we have discussed like maybe x raised to power. What happens if it's a combination of two functions? What happens if there are two functions maybe like this? Okay, so what to do in this case, for example? Okay, so we'll learn some rules. Okay, that the ultimate aim is that we want the combination to be to find the change of combination with respect to the change in variable. Okay, so that is the aim, and for that again we will see that some rules which are there. Okay, so let us begin with the first thing, that differentiation of a constant function. Okay, as the name suggests, the common
Constant function means x equal to 5 if I say. Okay, so for this, irrespective of x, okay, whether x is 1, 2, 3, 4, it is not changing. Obviously for that it should be 0 because this number actually represents the change. Okay, derivative of the sum. Okay, now this is again you will find too frequent. Okay, if there are two functions, suppose if I say x square plus x, what will be the derivative of this? So we can treat this as one function, treat this as second function. Okay, so this we can write y dash as will be u dash plus v dash. Now remember when we do differentiation we can write dy by dx. Okay, we can write this as y dash f dash x. Okay, in some books you will also find the capital D notation. So capital D means d of dx, and whatever, suppose if I am writing dy, so it means d of dx. Okay, dy by dx. Okay, so going through this, the next rule will be, okay, this is already what I have written. Okay, just overlapping that. Okay, yeah, product rule, again I'll explain it in detail. Okay, product rule is when, like I said in this, okay, that when the two functions are different. Okay, so what should I do? Should I simultaneously differentiate? Should I differentiate only one of them, or what should we do? Okay, so in product rule, basically if there are two functions like in this case, okay, so the rule is you keep first function as it is, differentiate second. Okay, then you differentiate first, keep the second one as it is. Now this is the product rule. Okay, product rule differentiation. So in this, first I am going to differentiate ln x or whatever be the case. Okay, you can take the other way around. Ln x is 1 by x plus, for this it is n raised to power this one and ln x. So you can clearly see that for this we are keeping first function as it is, second derivative of second, and then second as it is, derivative of the first one. Okay, chain rule, again chain rule is a bit similar to this, but yeah, the only difference will be that it's a function in function. Okay, so here what happens if I say ln x raised to power n, this is a perfect. Okay, so chain rule will be always a composite function. Now all of us know what a composite function is. Okay, so basically when we are differentiating a function, okay, we always differentiate whatever lies inside. Like suppose if I am going for this one, what I will say, let ln x be t. So first what I'll do, I'll follow the this rule, x raised to power n rule. I'll put it as, okay, then again I'll differentiate this with respect to x. This is what the chain rule is, okay. So the chain rule basically says that first go by the outer function, okay, whatever is that, follow a rule which we have already learned from standard derivatives, okay, and then differentiate whatever lies inside, okay. This also is applicable to x raised to power n, okay. Here what we can say, one function is x itself and the other function is the power function, that is raised to power, okay. So here what we are saying, first go for this by the rule which is this thing, and then if I differentiate x with respect to x, it gets 1. So here this quantity is actually 1, so it's not putting any difference. But suppose if I say x square raised to power n, or maybe in this case like ln x raised to power n. So what we are doing, n into ln x raised to power n minus 1, and then we will say that we will differentiate this also with respect to x, that will be 1 by x. So chain rule goes like this. Then quotient rule, okay. In quotient rule again, here in product rule we had the case like uv, okay, this case which I have written here, okay. Now suppose this is the quotient rule is when it is in the form of fx over maybe gx, okay, like that. So in this it's very interesting, okay. So either there are two ways, either you can make it product rule. How? You can just write it like this, x raised to power n and ln x raised to power minus 1. Now this becomes product rule, okay. But this sometimes the functions are such that it's really difficult to cater like that. So the rule for this says keep the first function as it is, means the function which is in the denominator, okay. Go for the upper one, differentiation of this, then minus, okay, remember the sign minus, first function as it is, derivative of second function, and this is not the end, okay. In the denominator comes this square, ln x whole square, okay. So this is again, I'll write it again here, okay. So this is again product rule. You can just, all of you can just note now, uv, if I want to differentiate these two functions, so rule was u into v dash plus v into u dash. Chain rule again was self-explanatory, that function in function, okay. So first you need to, if I write that as u v. Now here what does it means, like when I'm saying ln x raised to power n. So what is this basically? So u of something is basically that thing raised to power n. If I write this thing, and x I am saying is equal to ln x, or basically you can say ut is equal to t raised to power n, and this is equal to, okay. So this goes like this, that u of v will be, first you will differentiate the outer one, then you will differentiate the inner one, and you will go up to you end up at, maybe there might be three functions inside, so you will go and until you get dx by dx, okay. So you will continue, because this is one, after this there is no use, okay. For the quotient rule, it goes like d of u by v over dx. Now in the denominator it's clear, v square, okay. So first we'll keep v as it is, u dash minus u into v dash. This is how it goes, and I guess dash notation is clear, okay. This means basically du by dx, this means dv by dx, okay. So let's do a question based on whatever we have discussed, okay. Find the dy by dx if y is equal to x square plus 1 by x, okay. Now again most of you will start doing immediately, okay. So sir told something like p by q, and then we will keep q p dash minus p q dash. But wait, first always try to simplify the things, okay. If I simplify this thing, what I'll get, x plus 1 by x. Now it becomes so simple, okay. Derivative of this is 1, and for this will be minus 1 by x square. Now you must have been familiar with this. If you would have followed the question rule, again I'll demonstrate by that also. We'll keep x as it is. Now derivative of this thing, for x square will be 2x, for 1 it will be 0. Why? Constant, I've already told that differentiation of constant is 0, minus the first function as it is, and this one is goes like 1 only, okay. Denominator x square. So this is again 2x square minus x square minus 1 by x square. So this one goes x square by x square 1 minus 1 by x square. So no matter which rule we follow, ultimately things are gonna end up at the same answer, okay. So this was a very easy thing, like most basic example which I started with. Now here we are, the different thing you are gonna find is, like earlier we were doing like this only, maybe some power or this. Now we are making using combination of functions, okay. Let us look at this question, okay. Now this question comprises of some parts, okay. So 2 I'll solve, and 2 you can pause and then solve it, okay. So this one is easy, product rule, UV, okay. This one again is very easy, quotient rule, but this I'll do, okay, here. Okay, so what we will do, this is what you will say, this is U by V, okay. This color does not look good, okay. So yeah, this is also not good, so let me take some. Can you suggest? Okay, no, obviously not, okay. Yeah, so this one looks fine. So this one goes like this, V U dash minus V dash U over V square, okay. So what is V? The lower function, 4x plus 5, okay, into U dash, okay. U dash is 3 only. By now you must try to differentiate orally, like 3x plus 4, it's 3 only. Why? Because this will get 0, x power will get, again one thing I forgot to mention was, like suppose if you are having 4x, okay. So in this case you said, okay, sir told us that differentiation of this is 1, okay. That was 1 because it is 1 into x. Now if it's 4 into x, we can keep always constant outside. So if I get something like this, k times f of x by dx, so it is equivalent to saying k times d of fx by, provided k should be constant. If k is not constant, we will follow the product rule, okay, but k is constant, we can just take the constant out, okay. So minus, now we have to differentiate this, 4 into 3x plus 4, okay. So denominator 4x plus 5 whole square, okay. Now this is again, this one you can simplify now, okay. Now going for 4, C and D part, again both looks like similar part, okay. So questions like this you should always go by like this, powers, okay. I'll do D part as it looks a bit more complex, and otherwise you will say that, okay, he has done the easier part and left the difficult part to us, but that's not what I wanted, okay. So this one first will follow that rule, x raised to power n, okay. Let us assume for the meanwhile that whatever is inner thing, okay. So first we are going to follow the power rule, okay. So it says half, okay, and whatever is inside we don't need to worry for that, plus c raised to power minus half minus 1, okay. Now we will apply the chain rule. Now we will differentiate whatever is inside. So this will be 2ax, this will be plus 2b plus 0, and then it will be x only, so dx of dx is 1 only, dx by dx, okay. So this goes like this. In the similar manner you will try to do this, okay. So I hope that the examples which I have taken justifies the rule which we have discussed, okay. Practice some more problems and we will continue with some more difficult problems in the later parts. This is just the beginning. Make yourself comfortable with the different rules and whatever functions, whatever things we have discussed till now. If you have any doubt in this topic, you can post it for free on askIITian website. For this, just visit the askIITian.com, and there you can visit discussion board. It will direct you to Ask Expert, where you can select the category, and according to the category post your question and click the Get Answer button. Experts at askIITian will answer your query within 24 to 48 hours. I hope all the rules which I have mentioned, like quotient rule, the product rule, the chain rule, the differentiation of a constant function, they are clear to you, and the illustration at the end made it further clear. In the next part, we are going to start with the logarithmic differentiation, from where the actual JEE stuff starts. This was the base which we have built now. Practice some questions based on whatever we have done till now, and come prepared before the next part. Stay tuned for the next part.